Bismillahirrahmanirrahim. Assalamu alaikum everyone. Today we are going to conduct lecture number 12 of our course Microprocessor Systems and Interfacing. And today's topic is basically the practicing different assembly language program. So we will be covering various examples to understand the various instructions of PIC microcontroller. Okay, this is the very first example that we are going to do in this lecture. So it says add the content stored in the location 08, 09 and 08. So there are some information uh, which is stored in 08, 09 and 0A location. So this is our 08 H location, 09 H location and 0A H location, right? So there is some certain information stored. We are not aware about what is the information. So that is why I just mentioned XX. So it could be anything, any value stored inside. So there are some information is stored, and uh, then what we have to do, we have to add the content. So we have to call them, insert certain registers to add them up, and then we have to do what? We have to store the result in the location 04 hex. That means whatever the result would be, it should be stored in 04 hex location. And again, we don't know what will be the output. That is why I just mentioned here XX, right? So that is the program that we're going. So let's start our program. Our program is, very first thing what we can do, we can actually add the information present in 08 location and 09 location and 0A location respectively in working register. So first of all, we need to clear our working register. So let's clear our working register. So we will write move little to working. Let's say 00 hex. So this means our working register will become empty now. Just to put 00 hex or inside the working register, that is a function of this instruction. The next thing what we will do now, our working register is empty or the value is 0. We will add the value of working register with the file register, let's say for the first location, which is 08. So our first location will be added with working register, add working with file, and which file we are interested in, 08H, and we will put the result in the working register. So what we are doing, we are adding W plus 08 location, right? Location, or let's say file register at 08H, right? And we are putting the result inside working register. So this is our uh, purpose of this instruction. So what will happen after this instruction? The location, the content of working register will be added sorry, content of 08H location will be added in this working register. So working register will hold information stored inside 08. So what will be our next instruction? We can actually add one more time, add working with file, and this time we will add 09H with working register, and again we will hold the result uh, inside the working register, right? Inside the working register. This time we will be adding F09 hex, and that will go in working register. So this is how. So what we have done so far, we have actually added these two content. Let me show you. 08 and 09 both have been added, and result have stored inside working register, right? It is quite possible that while you were adding these two values, there may be a carry generated which will be stored inside working register, inside status register. So we need to know that maybe there is a carry which is stored in status register. So next time if we add, okay, let's say we write another instruction, add working file 0AH. This time we are adding location number third location, which is 0AH. And this time we will be adding, we will also store information in the working register. But possibly if there was a carry in the last result, which is obtained after the addition of 08 and 09 content, so we may miss that particular carry. So to avoid the missing that particular carry, we have to use a different command, which is add working with file with carry. So this time we not only add working register with file location 0AH, rather we are also adding carry. If there is a carry, so it will also be added. If there is no carry, it will not be added, and result will go again in working register. So I hope you have understand the concept, what is difference between add working with file and add working with file with carry. So in the previous command, we were adding only the content of working register and the file register, but right now we are adding not only the content of working register and file register, but also if there was any carry in the last operation, right? So that is our first operation. Remember, uh, this is our first operation. This is our second operation. So there was maybe because first time in first addition there was no carry, because the result was it was added in the 00H. The next time it was added into 09H content, so it might possible that 09 this time you have a carry. So in third operation we need to take care of this specific carry, and that is why we have used add addition working with file with carry, right? So now our result is basically present in the working register, and all these three informations which are stored inside 08H, 09H, and 0AH have been added to working register. Now we have to go to again go to the question, and question says we have to store the result in 04H location. So what we have to write, we have to simply move the working register, move F, move to working register into the file, and which file register 04H. That means what will happen, whatever the content or whatever the result stored inside working register will go to file location, and at what location, at 04H location. So hopefully you have understand this example. In this example, what we have learned, we have added location 08, 09, and 0A content, and first of all we added them and we stored them in working register, and when they're all together added, then their combined result is forced to move inside 04H, which is the purpose of this program. Okay, in this is example number 2, and in this example we are going to take another application of PIC-18F microcontroller. So this example says use PIC-18F452 as a printing device and data coming on port B. That means data will be coming on port B uh, from outside world. That is kind of input port. As you can see, this is a PIC-18F452. This is our port B, right? This rectangle, red rectangle shows port B, and this input sign indicate this is an input port. So data must be coming on port B, and it must be printed by printer, which is connected to port C. That means the port C will serve as output port, and there will be some output peripheral device, which is in this case will be a printer, will connect it to that port C. So whatever the data coming on the port B, we have to print it on the port C. So what we have to do, we have to send, we have to take information from port B and send it to port C. And that is this, that is the function of PIC-18F452 in this specific example. So it is kind of application program, so it will be burned in the microcontroller to perform this task. So what we have to do, we need to know that there is some input involved, there is some involvement of output, so that we need two different ports. One is port B, which will be used as input port, and other is port C, and that port will be used as an output port. So port B will be configured as input and port C will be configured as output. So that is the first thing that we have to do in the code. So let's say move literal to working. I hope you remember, if you want to configure a port as output port, you have to send uh, 00 hex to that specific Chris, right? So in this case, we are interested to make port C as output port. So we will send 00 hex or 0x00, and first of all we store the information inside working register. Next thing what we are going to do, we will write move working file, and these value will send to the trace C. That means it will make port C as output. So what we are doing, we are making port C as an output, right? And similarly, we know that every port by default is input mode, so you can you can avoid the configuration of port B. But if still you want to configure, what you have to send 1 1 to each bit of tris B. So if each bit of tris B is going to be 1 1, that means the information will be in hexadecimal F F, because 4 times 1 will become F, another 4 times will become F. So 8 bits 1 equal to FF hex, right? And we have to send that information to move working file to tris B, just to declare port B as input. So this is the configuration setup, that how you declare port C as output port and how you declare port B as input port. Next thing you have to do, you have to collect the information from port B and send it to port C. Here we will be learning a new command, which is move file to file. That means we are having some information in certain file register, and we will move it to from that file to another file location. So here we know that port B and port C are nothing but the specific special function register present in the file register. So we will be having information from port B and we will send it to port C. So syntax of this command is very interesting. You need to understand the concept that move file to file is a mnemonic, and port B is the destination, is the source operand or the source file register location, which is port B. So we will be having copying the information from port B and will paste it in port C, which is the another file location, port C. So in this way, information which will be carrying from port B or carrying towards port B will be collected by a microcontroller and it will send to the port C, which is again connected to output device. So this is the function that we want to perform by this specific microcontroller. So we know that this is the only task that will be performed in this application. So we need to repeat this task for indefinite time, right? So how we can do it by using by putting this instruction into infinite loop, and that we can do using short branch, which is branch, right? And we have to let's say place a label. So this branch command will jump to this ABC level, and this level must be introduced somewhere here, ABC. So what will happen now, that this branch instruction will copy the will jump this from this jump to this label, and this label is defined over here. So what will happen, that this this instruction will be repeated for the indefinite time interval, and uh, whatever the data coming from port B will be printed on port C for indefinite time interval. So that is the application program that we are doing very first time. So in this program, we are using both input and output port. Hopefully you have understand the concept of input output port in PIC microcontroller. Okay, one thing which is important to note here, that this instruction move F to F, we are using it very first time. So you must remember the syntax of this instruction. What is it? Move F to F is mnemonic, and then we have to show the source file and comma and then destination file. So what will happen, this will actually copy the content from port B, right, or source file, that would be more appropriate, and it will send to paste inside destination file. So this is the concept of this instruction, and this is very useful instruction that you can use in various applications. So this is one of the learning uh, or one of the enhancement of in your knowledge in this example. Okay, this is example number 3, in which we are going to see another application of PIC 452 microcontroller. So first of all, let's read the statement. So statement says connect 8 LEDs with port B of PIC 452. So what we have done, we have connected 8 LEDs. LED 0 is connected with pin number 0 of port B. LED 1 is connected to pin number 1 of port B, and LED 2 is connected to pin number 2 of port B. And similarly, we have connected 8 different LEDs which are numbered from 0, 1, 2 and up to 7. So This is the output port, of course, because these are LED devices or output devices, right? So turn on these LEDs. We have to turn on these LEDs in the following patterns, right? What patterns? First of all, pattern number one says LED 0, LED 2, LED 4, and LED 6. That means 0, 2, 4, 6. So these alternative LEDs must be on, and then alternatively another pattern which should be switch LED 1, LED 3, LED 5, and LED 7. That means first we turn on the even number LEDs and then we turn on the odd number LEDs. So we have to switch between these two patterns for indefinite time of interval, right? So we will use PIC 18F452 for this application. So let's write our code. We need to know that first of all, port B must be used as output port. So we will make it output port. So move literal to working 00 hex. That information will send to the port B, and then we will send it to Trust B. Sorry, not port B. Trust B. Move working file Trust B. So what we have done here, we have configured port B as output. That is the purpose of these two instruction. We have been seeing these kind of examples, so I hope this is clear to everyone. And now what we have to send some information to turn on these LEDs. So remember what we have to do. We have to send this information. LED 0 means we have to turn on the first LED, then second LED should be off, then turn on, then off, then turn on, then off, then turn on, right? So and then turn off. And then this is our first pattern. Next pattern would be what? 0, because it should be turn off. 1, 0, 1, 0, 1, 0, and 1, right? So this is the pattern. The second pattern, in the first pattern we have just turned on the even number LEDs, because 0, 1 is off, then 2 is on, then 3 is off, then 4 number is on, and so on. And similarly in the next pattern, what we have done, we have turned on the uh, odd number LED. So what is this number in hexadecimal? 0101, that is 5, and 0101, that is also 5. So we have to write a code that we have to send this information, move literal to working. The code is 55 hex, and we have to send it to what? We have to send it to port B. Move working file port B, right? Okay, let me just adjust them for a while. So that means, first of all, this information is sent. What information? 55 to port B. That means this LED, this LED, this LED, this LED, right? This is the pattern. This is the first pattern that we're gonna use it, right? And next pattern would be what? To switch them, just we have to what? We have to whatever the bit was on, we have to turn it on, right? And whatever the bit was on, we have to turn it off. That means we are complementing this binary information. So there is one way you can use AA, because 1010 is A and 1010 is A. And again we can simply just change the information by sending it to move literal to working AA hacks and send it to port B. This is one way you can also do it. But what else you can do? We can use another command which is called COMF, right? Or complement file. So whatever the file we have information already, port B is sent with this information. Now we have to just complement the data. Whatever the bit was on, we have to turn it off, and whatever the bit was off, we have to turn it on. So we have to complement the data. So we are complementing this file. What file? Port B. So whatever the information present on the port B, it will be complemented. That is the reason the LED which was turned on, it will be turned off, and what LED which was basically the earlier off, it will be turned on. So that is one of the instruction that is new learning in this example. So this is important instruction. I hope you have understand it, right? So COMF means you are complementing file, which file? Port B. And now we have to switch this pattern. So for indefinite time interval. So how we can do it? You can use a short branch here, branch, and let's say ABC, and this label can be used here, ABC. So what will happen? You will be uh, uh, looping this instruction for indefinite time interval, and that means these LEDs will be alternatively glowing in these pattern number one, and then pattern number two, then it will switch back to pattern number one, and then it will switch back to pattern number two. So hopefully you have understand the concept. So we have learned a new state instruction as well, which is complement file, right? I hope you have understand. If you have any query, please note them down for your session as well. Okay, let's cover another example, which is example 4 of this lecture. So what we are doing, we have PIC microcontroller. So it says use port B and port C. So this is port B and this is port C as input port. So these two ports will be used as uh, input port. That means both of these port will accept certain information from outer world, and port D will be used as output port. That means this port D will be served as output port. So some information will be sent out from this port. So 8-bit numbers are being received at input ports. That means 8-bit information will be received at this port, and 8-bit information will receive at this port. So what we have to do, add these numbers. So information coming from port B and port C, we have to add them and send the result. Then the summation will be sent to the output port, which is port D. So let's write the code for this information. First of all, we need to know that port B and port C both are input, and port D will be serving as port output port. So we don't need to configure port B and port C because they are already by default every port in port input mode. So port B and port C will be in input mode. So we will not configure, but port D should be configured. So we will write move little to working 00 hex, and we will send this information to which file register, which SFR should be sent to tris D, right? So that D will become, or port D will become as or configured as output port, right? So this is the just configuration of output port. And what we have to do, we have to collect information from port B and port C. So how you can do it? We know that we have instruction to add file and working, but we don't have any information in working register right now. One information is coming in one file. So this is our one file, which is port B, another file is port C. So both informations are basically present in two different files. So what we have to do, so first of all, we will uh, put one of the port result in working register. So how you can send file information into, or a specific file location into working register, we will be introducing a new command, which is MOVF. That means move file, right? So we have to move this file into certain location, right? Which file? Port B. Let's say we are moving port B, or moving file which is port B into working register. So what will happen? It will send the content of working register, sorry, port B in to working. So this is the function of this command. So now our one information is present in working register, another present which is port C. So now we have one information in working register, another information in file register, which is port C. So let's add them up, and we know a very useful information, which is add working file. So we are adding working and file. What is present in working register? Whatever the information came from port B is present in working register, and what file we are adding up? Port C. So whatever the information present on the file register will be added, and it will send to the working register. So now we have result in what? In working register. So both of these ports, port B and port C, are added, and result is present in the working register. So now we have to send this information to port D, which is output port. So move working file, which is very easy and very uh, frequently used command. Move working file, and what file we are s- sending working register to, what file, port D. So in this way, result will be displayed on port D. And remember, we have to repeat this information. If you want to repeat this information for indefinite time interval, you can simply input these three instructions into the loop. And how you can do it, using short branch instruction, which is branch, right? So branch, let's say I want to repeat, so I can use any variable. So xyz is our label, and here we will put this xyz. So what will happen, this these three instructions will run for indefinite time interval. And what will be happening, uh, data will coming from port B will go to W register or working register. Then this working register will be added to port C, and result will store into the working register, and then this working register will send to the port D. So in this way, port B and port C will get added, and result will go to port D. And this particular application will run for indefinite time interval. One thing I want to mention here as a note, that we haven't used any assembly directive like originate 0 0, originate 2a, or and, because those are understood things, and you need to write them whenever you are going to write them in MPLab environment. I will also suggest one more thing. Please perform these application program in Proteus environment, so that you can verify and check your skills, whether you are going uh, well or not. Thank you so much for listening. If you have any question, please post them in comment section. Thank you so much for listening.